So in the last video on the basics of data frames, we saw how to build a data frame from scratch, how to select rows and columns from a data frame, and how to add or remove new rows or columns. If you would like to watch that video before this one, the link is provided in the description box and pinned in the comments section. Now remember, you would hardly ever need to create a data frame from scratch, but it's good to know how to do it. Mostly, you would be importing CSV or Excel files or reading data directly from some online sources or repository. The process for doing that would be explained at the end of this video. Apart from that, we will also see how to do conditional selections in a data frame using a single or multiple conditions, how to set and reset index, how to work with multi-index data frames, how to deal with missing data, the use of group by object in a Python data frame, concatenation and merge functions to join multiple data frames into one, and some other operations like finding unique values, sorting a data frame, and pivot tables. So let's get started. So we will start by first importing some libraries and then building a data frame from scratch for the further work. So let me start by importing NumPy and Pandas. Import NumPy as NP and Pandas as PD. Next I will import rand_n from numpy.random to generate random numbers for my data frame. So from numpy.random import rand_n, and I will also drop a seed here, np.random.seed101. By using this seed, if you are following the steps as me, you will get the same random numbers. Now let's build our data frame. We'll name it df pd.dataframe. D is capital, press tab. Then we will use the rand_n and will generate a 6x2 or 5x4. We will use rand_n and generate a 5x4 data frame. If you press shift tab and see here, we need data to generate a data frame, and then we need index and we need columns. So for index, I'm going to use a list. I need 5 labels here. I will use characters A, B, C, D and E. And for columns, I will use W, X, Y, Z. Now let's check our data frame. If you would have dropped this seed 101, then you would also get the same random numbers. And so if you are working alongside me, then you should get the same answers as me, and you can match if you are doing it correctly or not. Now let's move on to the conditional selection now. Before we do that, let me show you something. If you use a condition with this data frame, it will return a data frame of boolean values. For example, if we check if df is greater than 0, then for each cell it will return either true or false based on whether that value in the cell is positive or negative based on this condition. Here I ask for greater than 0. Now if you pass this thing within the data frame, then the data frame will return the values in the cell where this condition was true, and where it was false it won't return anything, therefore it will have a null value here. So wherever the value was negative in the original data frame, we got null, and we got the values for all the positive values here. So you will never be using a condition on the entire data frame. Most of the time we will use conditions on a column or row. Depending on the data frame, you would either use a condition on a column or a row. So for example, let's take this column W here. It's a series. Now let's check for value greater than 0. So it should return a boolean series with trues for all the index where the value is greater than 0 and false for index where value is less than 0. So we got that. Now if you pass this within the data frame, so see this data frame return a new data frame with index for the true values, and where the value was false in the series, it dropped that index. So it will return a data frame with only the index which satisfies this given condition. This is called conditional selection. Now since this is a data frame, you can index any particular row or column from this as well. So let me show you. We have our data frame. Suppose you want to index and select column Y here. So this will return a series again for just that column Y, and the values will match here. In case you want to select multiple column, you will do the same way as we do with our data frame. This entire thing is now the name of a data frame. You can assume it to be that, and then for multiple columns you can pass in a list of the column names. So uh, let's say we want to index column Y and column Z here. So pass in a list for that, and it will return a new data frame with those index. Now you can see here, if you check the type, this is a series and this is a data frame. So if you index only a single column, it will return you a series, and if you index multiple columns by passing a list, it will return you a data frame with just those index. Now we will move on to multiple conditional selection. So here we have put condition in just one column, but what if you want to put conditions in more than one column? Let's say one column has to be greater than 0, but the data in another column has to be greater than 1 as well. So in that case we have two options, and or. These are called logic operators. Logical operators in Python. So what it does is it helps you to select the data based on conditions applied on multiple columns. So this and or here are called logic operators, and returns a true if both given conditions are true, like true and true. If you want to see true and true, it will return true, or returns a true when even one of the conditions is true. So if you check here, true and false, this will return a false because only one condition was true. But if we change this to or, it will return a true. Only one condition has to be true for this to be entire thing to be true. So and returns the intersection of two conditions, that is values which satisfies both of the conditions should be returned, and or returns the union of two conditions, that is values which satisfies even one of the conditions should be returned. So let's do that now. Here let's say, so we have our data frame here. You know how to use condition for the single column. Let's say we want W to be greater than 0, so we can pass in df of W greater than 0. This will return the data frame where this column is greater than 0, so it will drop column C. Now if you want to use multiple column, you can put this into a parenthesis and use and or operator and use another condition. So let's say we want Y to be greater than 1 as well, which is only one column E. So this should return a data frame with only one column, because for the first condition 4 rows will qualify that, A, B, D and E, and for the second condition only one row will qualify E, and because AND is intersection of these two, so only E will qualify out of this entire condition. This has to be greater than 1. Now this will return an error. Let's check this. It returns an error which is value error. The truth value of the series is ambiguous. So what's happening here is this condition provided me 4 rows and this condition provided only 1 row. Now AND doesn't know how to compare two series or a series with a scalar or single value. It can only compare two single values, that is true and true. If there is a series of truth and false and another series of truth and false, and we cannot use AND for that, but we have another operator in Python for that, and we can use, rather than AND, we can use ampersand. And now when I run this, it will work. So for this conditional selection, in place of AND we have this ampersand sign, and I will use the same condition here for the OR operator, and for OR you can use a pipe operator. Pipe operator is given directly above the enter key on your keyboard. If you run this, this should return 4 rows. See, we have A, B, C, A, B, D and E. We have A, B, D and E here for column W, which was greater than 0, and for column Y, one row was greater than 1. And because we are using OR operator, which is a union of both, so we will get all 4 rows A, B, D and E. And when we use the AND operator, which was an intersection of the two, then we got only E, as E was common between those two conditions. Now next we will move on to reset index and set index. So we have this index here in the data frame. Let's say you want to reset it back to the default range index, which was 0 to n minus 1 for n rows in a data frame. So if you have n rows in a data frame, the default range index will go from 0 to n minus 1. So the way to do this, we have a method for this. You can use reset index, start typing and press tab. And if you check the signature here, we have a level argument, and then we have drop, in place, and some other arguments given here. Level is used for multi-index data frames, that is when a data frame has more than one row index. We will talk more about these in a while. Next, pass the argument drop as true if you don't want to retain the original index, which is inserted in the data frame as a column. By default, it is given as false, and in place is used to make permanent changes to the data frame. By default, it is given as false so that we don't accidentally change the data frame and lose data. But if you want your changes to be permanent, then you can pass in place as true. So let's run this and see what happened. So our index got converted as 0 to 4 for 5 rows. So this is now a range index, and the original index which we had, that got transferred over to the data frame as a column. If you use drop is equal to true, then it will simply drop this index here. So it will return just the original columns, and the index will get converted from the levels into a range index. Now if you check the df again, it has retained the original levels here. Had we used in place argument and return true for that, then this will be dropped for real, and if we try to use df again, we will get this data frame, but we won't do that for now. So what we will do now is we will move to set index. Now set index is, if you have a particular column in your data frame which you want to set as an index here, then we can use the set index method. So we have our data frame. Let's add another column In the data frame, we'll call this states, and I will use the split method here. I will pass in a string and use a split method. This will create a list of 5 values and will append that as a column in the data frame. So these are US states, and let's check RDF here. So now we have got our data frame with a new column which is states, and we will use this column to set as the index now. So you can use the set index method, and here we need to pass in a key which is the column name for the column you want to set as an index. Then again drop is true by default, so that will drop this column, and in place is false. Drop is true by default. This will delete the column to be used as new index. So if we use this states column for our index, it will get dropped from the data frame. And if you turn append is equal to true, this will append this column to the existing index. So it will create a multi-index data frame here, and in place is false by default. So let's pass in our states. So now that states column has been converted into an index of this data frame. However, if you recall this data frame, you will get the original data frame back because we didn't use in place is equal to true here. If you do that, we won't get this. Next, we will move on to the multi-index data frames. So for this multi-index data frame, I have some piece of code written here. Let me run this and show you what we have. Multi-index data frame will have more than one level of index. So for example, say we have two values here in this outside list, G1 and G2, and for both G1 and G2 it will be further divided into 1 2 3 1 2 3. So both G1 and G2 will be further divided into 3 rows. So let's see what is outside list. It's a list of 6 elements, G1 G2 G3, sorry, G1 G1 G1, G2 G2 G2. Inside is a list of 1 2 3 1 2 3. Then we use a zip function to zip this list, and we get a zip object at this location. So to check this, we can convert this to a list, and it will return the zip which converts the corresponding elements of this two list into tuples. So the first element of this outside list goes with the first element of the inside list, and it will create a tuple for that. So this returns G1 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 1 G1 2 G1 3 G2 1 G2 2 G2 3, and we use a list for to put all of these tuples inside a list. Then we created a multi-index from that using from tuples. So let's check this higher index. So we created a multi-index from tuples using this higher index object, which was a list of zip of these two, outside and inside list. So it created a multi-index. You can see it's a one-dimensional array. It has 6 elements: G1 1, G1 2, G1 3, G2 1, G2 2, G2 3. Now we will create a data frame using this index. So df is equal to pd.dataframe, and we will create random numbers here. We will create a 6 by 2 data frame. For index, we will use this higher index object which we created, and for columns we will pass in a list A and B. So this will be the column names. Let's check our data frame, and it created a data frame which has two levels of index here. G1, G2. Both G1 and G2 are further divided in 3 rows, 1, 2, 3, 1, 2, 3. You can check the index name here, index.names, and we don't have any name here, so we can give some name. You can pass in a list of 2 elements in this format. So let's say for the outside we'll call it group because it starts with G, and for the inside we will use num. And now if you rerun this data frame, so it will return the same data frame with index name which are group for G1, G2 and num for 1, 2, 3, 1, 2, 3. Now let's show how to index this. For index hierarchy, we will use df.loc with bracket notation. If this is on column axis, you would just use normal bracket notation with df. Calling one level of the index returns the sub data frame. So let's index this. We have our multi-index data frame. Let's see, you want to see data for a column. For column it's simple, you will just index it for the column and it will return a series. That series will have multi-index. So for the series, it's a multi-index series. So if you want to further index G1 or G2, you can pass in G1 and it will return a series, and then you can index it for 1 or 2. However, if you want to index the rows, if you want to index G1 or G2, you can use .loc method and pass in G1, and this will return the inside part of that data frame. So see here, for G1 it will return this portion, for G2 it will return this portion. Now this is a data frame, so you can further index it. Say if you want data in the second row, you can further use .loc method and pass in 2 here, and it will return these values -1.7 and -1.15. However, if you want to index the data frame based on this second level index, let's say you want data for row 1 for both G1 and G2. For that we have a method called cross section. So we have our data frame here, use access method, and there we can pass in the key which is the index level. Then we have axis 0 for rows and 1 for column, and then we have level. For multi-index data frame, for multi-index you would have labels 0, 1, 2, 3, or you can pass in the name of the level as well, so that Python knows in which level you are looking for that key. So let's see this with an example. Let's say I want to index row 1 for both G1 and G2. So I can pass 1 here, but this will return an error. And this error is a key error. See, key error. And it's a key error because it cannot find 1. It is looking to find 1. So what Python did here was, it was looking to find 1 in this outside group or the level 0 index here. It says level none, but by default it is 0. In K, in case of key partially contained in multi-index, indicate which levels are used. Levels can be referred by level or position. So you can use the level here either by group or num, or by positions, which is 0, 1, 2. It starts from outside as 0 and goes inside. So it starts from outside as 0 and then inside index should be 1. So you can do that here. We'll pass in our level. You can either pass in 1, that will work, or we can pass in the level name as well. So now it will return the rows for this level 1 here for both G1 and G2. This entire thing is a data frame as well. If you want to select this row here, using the cross section, you can directly pass in a tuple with G1 and 3. Next, we will move to the missing data here. For the missing data, we have two options. Either we can drop those rows or columns or fill those empty cells with some value. Now there is an entire theory of how those value can be filled. Some use average, some use medium. It really depends on the kind of data you have and the field from which you have that data. So you can Google and read more about it. For now, we are just going to see how to drop those rows and how to fill the value here. So before that, we will create a data frame which has empty cells. Df is equal to pd.dataframe, and what we will do here is we will use a dictionary to create a data frame with empty cells. So A would be first column, and we will use np.nan here for empty cells. For B, we will have 5, then np.nan, then np.nan again. So this will have 2 empty cells. And in the end, we will have column C, and let's say that has all data, that doesn't have any empty cells. Let's check our data frame. So we've created a small data frame where column A has 1 missing value, column B has 2 missing value here. Now we will use drop na. Let's say we have this data frame, you want to drop the rows which has empty cells. You can just use the method drop na and it will return the data frame. It will drop all the rows which has empty cells, and it will return the data frame with the rows which doesn't have any missing data in them. Now if you want to do the same thing for the column, that is, you want to drop the column and retain only the columns which doesn't have any missing value, you can pass in a parameter for axis. So let's check the signature here. We have an axis argument which is given 0 as default. 0 is for rows. If you want to drop columns, you would have to turn this to 1. It will drop the columns A and B and return the data frame with only the column C which has no missing values. And there are some other parameters here as well. One of these you should know is thresh parameter, and what this does is it requires that many non-NA values to be retained. So here we have our data frame. We use drop NA to drop the rows. Now let's say we put the thresh value as 2 here. So what this thresh does is it requires that many non-empty cells in a row to be retained in order to be retained. So here both 0 and 1 had at least 2 non-empty cells. So both 0 and 1 got retained and 2 got dropped and it had less than 2 non-empty cells. Now let's say rather than dropping this, you want to fill some value here. So for that we have fill na method. Let's check the signature. We need to put the value which we want to fill there, and then we have other parameters like method, axis and in place here. So for the value parameter, we need to pass in the value which we want to fill the empty cells with, and then we have a parameter called method. There are different kinds of parameters given here. We have backfill. So what it will do is it will take the value from the next row or column and fill the empty cell with that value. Basically this methods will copy over the same value which is given in the data frame in the other cells in the same row or column, and we can use that same value to fill the empty cells here. axis is once again 0 for row and 1 for column. So if you want to copy the value from the rows, you can use 0. If you want to copy the value through the column, you can use 1 here. Again, in place, turn this to true if you want to retain the values. So what we'll do here is, let's pass in a value here, and I will pass in a string to show you what it does. So it took all of those NA cells and fill this value here. You can also use different methods to fill this. So let's say we have our first column here. We can use fill NA method, and you can pass in the value for this column. Take the mean of this column and fill the empty cell with the mean of the values in the remaining cells of this column. And similarly, you can fill other empty cells in the data frame as well. Next, we will move to group by objects. For this, we will create a new data frame. I have the data given here. Let's run this. And we will use this data to create a data frame. So I have this dictionary here. Let's run this, and I will use this to create a data frame. Let's check this data frame. So it has 3 columns. In the column 1 we have company name, in the column 2 we have person, and in column 3 we have some sales data. So we will use group by method on this data frame. What the group by method does is it groups together rows based off of column names. So for example, we can group the Googles together and use some arithmetic of the remaining columns to get, for example, you want average of Google, we can use group by to group the both Googles together and we'll find the average of this sales column. Similarly for Microsoft and Facebook. So let's group by this data frame. So we have a by parameter here. Axis is 0 by default, 0 or index or 1 or columns. By default it is 0. So we'll pass in the column name for which we want to group data. This will create a group by object. Now you cannot see the data just like that. We have to use an aggregate method of this object. So let's say we want to see the mean of this data. So to return an error, aggregate function fail how mean data type object. So basically, if you check the signature here for dot mean, if you check the signature, we have a parameter called numeric only, which is by default given as false. We need to turn this into true, so it will try to find the mean of only the numeric values. Right now it is trying to find the mean of the string as well, and obviously there is no mean of this string, so it was trying to find the mean of this person column. So basically for Google it was trying to find the mean of Sam and Charlie. That makes no sense, so that's why it returned an error. So for this arithmetic function we have to turn this parameter numeric underscore only to true. So what this did here was it grouped the data frame based off of this company column. So all of the same elements got grouped together. So we have 3 companies here, Facebook, Google and Microsoft, and then it returned mean for the sales. So for Google it was 160, for Microsoft it was 232, and for Facebook it was 296. You can also use this with other aggregate methods. Let's say you want to check the sum. Run this and see here. Once again, it tried to find the sum of the this person column, and sum for string is just concatenation. So it glued those two together. It means it has no meaning. If you don't want this column, you can pass in the parameter numeric is equal to true. Numeric underscore only is equal to true, and it will return only the numerical columns. Once again, you can check for max values as well. Now it will return max for string as well. Because if you check this data frame here, let's say for FB we have Carl and Sarah. So the way the strings are stored is based on the alphabets, and S will have a higher value than C as an index. So for Max it will return Sarah. For Google it will return Sam, and for Microsoft it will return Vanessa. If you check for min values, it will be the reverse. For FB, for Facebook it will return Carl because C is smaller than S. Then for Google it will return Charlie, and for Microsoft it will return Amy because A is smaller than V as an index. And obviously for the sales column it will return the lesser of the two values. We can also use count here, that will return the count of the values here. And the last one is we can use the describe method with this group by object. So for all three company names, it will provide this descriptive analysis of the data. It will do it obviously only for the numeric column. So for sales column, we have count, which was 2. Then we have the mean, we have standard deviation, minimum value, maximum value, 25th percentile, 50 and 75th percentile data here. Now next we will move on to merging, joining and concatenating. These are three ways of combining data frames together. The concatenating first, we have three data frames here. Let's run this and check the data frames. So we have data frame 1, which has 4 columns A, B, C, D and 4 rows ranging from row index ranging from 0 to 3. Then we have DF2, which has the same columns but the row index goes from 4 to 7. And then we have third data frame, which again has the same column but the rows goes from 8 to 11. So let's say we want to glue these data frames together. We want to concatenate this. So we can use the concat method and pass in a list of the data frame names you want to glue together. So what this will do is it will put these data frames one below the other. So we have data from df1, we have data from df2, and then we have data from df3 here. Because all the columns were same, so it will glue one below the other. Now if you check here, we have an axis argument here. Axis was given 0 by default. If you want this to be glued on the columns, you can use this axis parameter and write axis is equal to 1. So pd.concatenate, pass in your data frames as a list and then use axis is equal to 1 and see what it did. Because the index names were not same, it went 0, 1, 2, 3 for all three data frames. It will go below. So this is for first data frame, then the rows will go below that 4, 5, 6, 7 and the third one will go below that 8, 9, 10, 11. When we use axis is equal to 0, which was given by default, we had the same column names A, B, C, D, so it all got glued one below the other. Now for merge, we have two new data frames here called left and right. Let's run this. So on the left, we have three columns, key A and B. Keys K0, K1, K2, K3. On the right, we have key C and D, K0, K1, K2, and K3. So we have the same key column on both these data frames, and then we have different columns. So this merge function allows us to merge the data frames together rather than gluing it together, which we do with concatenate. Here we can use a column to join the two data frames. So you can use pd.merge and check the signature. We need a left data frame and a right data frame, and then we have an how argument, which is by default given as inner, and then we have on, that is the key we have to pass. So if you check the parameters, we have left and right, and then we have how. This has 5 values: left, right, outer, inner, and cross. So left means it will use all of the keys from the left data frame. Right means it will use all of the keys from the right data frame. So if there's any key which is in the left data frame but not in the right, that will get ignored. Outer means union of the both left and right data frames, or all of the keys from both data frame will be used for merging. And inner, outer means the union and inner means the intersection. So only the keys which are present in both data frames would be used, and the other keys would be dropped, other rows would be dropped. And cross creates a Cartesian product. So let's run this. Here we need a left data frame, a right data frame, a how argument, and on argument. So for left, we have data frames name as left and right. So we'll use left comma right. Then for how, we have inner given by default, so we don't need to use it, but here I am using it to show you. And then on, we have this key column in both data frames. So it used the key column to merge both data frames. We have column A and B from left and C and D from right. For K0, it was A0, B0 and C0, D0 here. And then for K1, it was A1, B1 and C1, D1. Similarly for K2, A2, B2, C2, D2 and K3, A3, B3, C3, D3. And we can use multiple columns as key as well. In that case, you can pass in a list of elements as key 1 and key 2. Column names could be anything. You can pass those as keys. So for merging, we merge based off of a column of the data frame. But if you want to merge based off the index, if the index are different in both data frames, if it was same, you could just use concatenate. But if the index is different, then we can use the join method here. So here we have two data frames with different index. Let's run this and check the data frames. So we have two simple data frames, but the index is K0, K1 and K2 for the left data frame and K0, K2 and K3 for the right data frame. And to use the join method, you can just use a data frame's name and use join method. If you check the signature, we have an other parameter where you have to pass in the other data frame you want to join, and then we have on, which is the key. It is given as none, so it will be index. And how do you want to merge those? So once again, if you check how, we have based on the keys from the left data frame or based on the keys from the right data frame, or you use outer if you want to use all of the keys from both data frame, inner if you want to use only the common keys which are present in both data frame, and then cross will create a Cartesian product. So let's pass in the right data frame, and by default this how is given as left. So by default it will use the keys from the left data frame, which is K0, K1 and K2. If you use left dot join, pass in right data frame and then how, You can pass in the right data frame. So this will use the keys from the right data frame, which is K0, K2 and K3. So it will return the results for that, or you can use outer, which will use all the keys from both data frame. And because K1 was not present in the right data frame, it will return null for that, and K3 was not present in the left data frame, it will return null for that. Next, we will see some other pandas operations in the data frames. Let's create a data frame for that first. We will use a dictionary for this. Here we will fill in some data for these three columns. A, B, C, D, E, F, G, H, I, and X, Y, Z. So let's run this with three columns. Column 1 has data 1, 2, 3, 4. Column 2 has three digit numbers 444, 555, 666, and then 444 is repeated. And column 3 has strings A, B, C, D, E, F, G, H, I, X, Y, Z. Now let's say we want to check the unique values in this column 3. So as you can see, in this is just a small data frame and we have three unique values here. So you can check the data frame. In the Python we have a unique function for this, unique method for this. In the Python we have a unique method for this. So start typing unique and press tab. It will auto complete and run this. So it will return an array of the unique values in that column. Now what if in place of unique values you want to check how many unique values are there in that column? So for that there are two ways of doing this. One is you have your unique values, this array. You can check the length of this array, which will return 3, or you can use an unique method, which will return 3 because there are 3 unique values in this column thing. There is another method called value counts, where you want both the unique values and the frequency of each value. So you will get to know how many times each of the value occurs in that series. You can use the value counts method, and so it will return those values and the frequency of each value as well. This is a very useful method to check the unique values and how many times they occur in the data frame. Next, we have an apply method which is used to apply functions to a column of a data frame, which is used to apply functions to a column of the data frame. So it will apply that function to each row, each value in the column separately. This is very useful for creating new columns in a data frame when you want to use the existing columns and change the value of that in some way. So here let's define a function called times 2, which takes in a parameter x and returns 2 times of x. So we have this function, and let's say we want to apply this function to each value in column 2. So you can use apply method and pass in your times 2 here. So it will double the value of each cell in this column. You can use inbuilt functions as well. For column 3, which is a string, we can use the apply method to apply len function. Len is a built-in function which is used to check lengths of the string, so it will return 3. If you check the data frame, so column 3 had strings each of length 3, so it returned 3 for each row here. Similarly, for column 2, it doubled the value of each cell and return that value here. We can also use the apply method with lambda functions. So to give you an example, let's say we have this column 2 here. I want to divide this values in half. We have this column 2. We can use dot apply, and then we can use lambda function here. X turns into x by 2. So let's run this, and it will divide each value by 2. Next, how if you have a data frame, how can you get the column and row index names? Uh, so we have this data frame here. Let's say you want to get the column names. You can use column method, and this will return you an index for the column names, which is column 1, 2, and 3 here. Similarly, if you want to check the name of the index, you can use the index method, and it will return you the index, which is a range index starting at 0 and running till 4. So it's basically 0, 1, 2, 3, because 4 is exclusive. If you use range function here, 0 to 4, this will return, convert this to a list, it will return 0 to 3 because 4 is exclusive here. Next we have sorting a data frame. Let's say you want to sort the data frame based on this column 2. So you can do that using sort underscore values function, passing your column 2, and if you check the signature, we have this by, which is index level. So here we are sorting for the column 2, and then axis is 0, so rows are getting sorted. If you want to sort it based on columns, you would have to pass in axis is equal to 1 here, and then we have ascending is equal to true. So data would be arranged from smaller to larger values. This is given true as default. So let's run this and see now that last index 3 has been moved up. How to check for null values? Now if you have a data frame where you want to check for null values, you can use isnull method, and in this data frame it returns false for all the cells because there was no null. But earlier when we created that data frame where there were null values, it would have returned null for 3 of the cells. Similarly, you can also check for NA. Is NA, it will return the same thing here. Next we have pivot table. So for that we will need to create a data frame. I will copy paste some code here. Let's run this. So we had this data dictionary with 4 keys and values given as list for each of the keys, and let's check the data frame here. So here we have this data frame. This is very difficult to read. What pivot table does is, if you know how to use pivot table in the Excel, it will arrange the data based on rows and columns. So it becomes very easy to read. So here we have this pivot table method, and if you check the signature, we have values, index and columns, and an aggregate function, which is by default given as mean. So for values, let's say we want this value. Then we have index and columns. So in index we want two columns to go, A and B. So we'll pass in a list for this. And for columns we want this column C to be as columns, given as columns. So let's run this and see how this has arranged neatly here. We have A and B as multi-index. So the outside index is bar and foo. For both bar and foo is further divided into 1 and 2 in this inside index. Column is the column C has been divided. The values of column C, there were two values in column C, X and Y. Those have been divided as columns. And now you can see the data for bar 1. For X we have 4 and for Y we have 1. So this turns an data in an Excel or CSV format into a readable table, and it is very useful for easy analysis of data based of index and columns. Next we will quickly see how to input and output the data from CSV and Excel files. So first we will read data from a CSV file. Let's see. We will read data from CSV and Excel files. So let's create the data frame. Let's name this TF. To read data, we have to use pd.read. As you start typing, press tab, and it will give you a range of options of reading data. So here we have CSV, we have Excel, we have HTML, SQL, XML, and you have range of ways you can read data. So we will use read underscore CSV here. And then if you have the file in the same folder in which you have this Jupyter notebook, you can read it directly using the name. Begin typing and press tab. It will give you the name of the files, CSV files in that folder. So you can do this if the CSV file is in the same folder. If not, you will have to provide the entire path for this. So let's check this. So it will give you the data here. We have this data. You don't really need to use a variable for this, but if you want to use that data, it's better to have a variable name. Now let's say we will write the same data. So if you have a data which you want to export in CSV format, we will use the same data frame. For this we have to underscore, press tab again. So it has all of the same objects from which you can read. You can write to those as well. You can write to CSV file, to Excel file, to HTML, and all of the other files. So here we will use the CSV object and then give a name and run this, and this will create a new CSV file with this table in your folder. Next we will read and write data from an Excel file. Pandas can read and write Excel files. Keep in mind this only imports data. It won't import any formulas or images or macros. And if your Excel file has macros, it may cause read underscore Excel method to crash. So to read the data, use pd.read underscore Excel method. Use the name of the Excel sheet. And for Excel, you will need to provide the sheet name as well. So it will read your data. If you want to store it to a data frame, you can do that. Let's say we have df is equal to 2. We have df2 here. df2 is this data frame. And then for the same data, we can write it to Excel using to underscore Excel method. We'll name it Excel 5. And once again, you can use the sheet name and give any name you want. Let's say sheet 5. Now, in Pandas, we can also read the data directly from online sources. For that, you will have to install lib these three packages. Either you can use conda install or pip install in your command prompt. You can use conda install if you are using anaconda command prompt, or use pip install if you aren't using the anaconda command prompt. Now, to read data from an online source, once again you will use pd.read_html and just pass in the URL. I have a URL of a website from US which has data of all the failed banks. Read this, and what this does is it creates a list. If you check df here, it will return some random stuff. That is because if you check the type, this is a list now, it's not a data frame. So what it does, it takes all of the tables from that website on that web page. It takes all of the tables from that web page and converts those into a list of elements, with each element be individual data frames. So you have to index through this list to find your data frame. Here I know that page has only one table, so that first element in the list would be this table I was looking for. And now this is a data frame. You can name it as such, and now if you call df2, it will return you this data frame. See, and you can use this data frame here. So there's a lot of noise outside. I'm going to stop this right here. So in this video, we went through basics of Pandas library and working with a data frame. After you have cleaned and prepared data, the next step is to analyze data. For this, we can use data visualization libraries like matplotlib and seaborn to plot various graphs, which helps us to easily infer information from the raw tabular data. More on this in the next video, which I will link at the end of this video and in the description box too. So that's all for this video. Until next time, see ya.